Hi everyone, my name is Artem Arakcheev and I am excited to present you the Quantum Copilot. This is AI assisting quantum computing. So the platform can help to anyone who wants to learn quantum technologies or to people who are actually interested in programming the quantum computers. The Quantum Copilot, you can ask any questions about quantum computing and get answers in just a second, stay up to date with everything that, with all the development that goes in the industry. You can generate the code and then you can run it on quantum simulators or even on the real quantum hardware. So we actually developed the conversational user interface to quantum computers so that everyone can just talk using human language and can program the quantum computers just by talking to them in the natural language. So we listed some of the features here. The Quantum Copilot includes chat. It can answer various questions about quantum computing hardware, software, algorithms, and everything else. It uses some information from the research documentations, papers, articles, books, blog posts, etc. Also kind of GitLab repositories. It can understand the Markdown and math.js formats. It can give some images, diagrams, math code. It can talk physics. It can generate the code on using various quantum computing languages, and it can simulate using either web simulators or a cloud simulator. There is a real quantum hardware that is integrated into the Quantum Copilot, and you can transpile the code between various programming languages and libraries, and you can run Jupyter notebooks, draw circuits, and there is so much more that you can do with it. And we are actually curious to learn what you can do with it. So here is an example of the code that was generated on the Quantum Copilot. As you can see, it understands many technologies, including Open QASM, Quantum Assembly, Qiskit, Cirq, QSharp, Amazon Bracket, and even JavaScript. There is some other technologies. So it can generate you circuits, images of circuits, the diagrams in SVG format, in text drawing, Quirk, and there is also additional formats are coming soon. So let's get started and learn how to use this platform. So to start with the Quantum Copilot, you will need to register. But then I already have login here, so I just log into this platform, and then let's just start talking about quantum computing, what is the quantum computing. Let's see what we can get from the Quantum Copilot. Quantum computing is an area of computing that utilizes principles of quantum mechanics, a branch of physics that explores the behavior of particles at the atomic and subatomic levels. In classical computers, information is processed and stored using binary bits, which represent either 0 or 1. However, the quantum computing quantum bits or qubits are used, which can represent both 0 and 1 simultaneously, thanks to a property called superposition. So let's ask more. What is a qubit? Let's see. it takes some time to generate the response, and here we get it. A qubit, short for quantum bit, is a fundamental unit of quantum information in quantum computing and quantum information science. It is a science. It is a quantum analog of classical bit, which is a basic unit of classical information in classical computing. And then there is much more we can learn from it. Then let's ask something more smart about quantum computing. For example, let's ask to generate example of quantum algorithm on Qiskit. Let's see. And here we have some example of quantum algorithm implemented using Qiskit. As you know, Qiskit is a IBM library for programming quantum computers. And it says which demonstrates the use of Groover's search algorithm. So we have a Groover search algorithm. Very interesting. Let's create our own quantum computing algorithm just by talking to the Quantum Copilot. Let's say generate a quantum algorithm with 3 qubits. Set qubit 1 to apply X gate to qubit 1, apply H gate to qubits 0 and 2, and apply Z gate to qubit 0, then apply the C node to control qubit 0 and target qubit 1. Measure all the qubits, write code in open cosm. Let's see. The open custom code for given quantum algorithm is as follows. Let's see, we have 3 qubits. We asked to generate quantum algorithm with 3 qubits. We see definition of 3 quantum bits and 3 classical bits. So we defined 2 registers with 3 qubits. One of them and another with 3 classical bits. Then we applied X gate to qubit 1. Here we have we applied X gate to qubit 1, and then apply H gate to qubits 0 and 2. Let's see, we have H gate on qubit 0, H gate on qubit 2, and then apply Z gate to qubit 0. Here we have it. And then apply the C node to control qubit 0 and target qubit 1. And then measure all the 3 qubits. So we got here the circuit that actually represents exactly what we asked on quantum assembler. Let's go to the page to run the code, so we can paste the code that was generated here, and then we can explore what we can do with that. First, we can run code on Quirk web simulator. So we can see this code. Actually, we have the gates, and then we can change the initial value of the qubits, and we see how our circuit reacts to those changes. We can even modify the scheme, the circuit, and even apply some dynamical gates into it and see how everything goes dynamically. So the Z gate actually rotates the value of the qubit around the middle of the sphere. And then let's try to use a quantum circuit web simulator, so we can see the state vector and we got the measurements, the probabilities and measurement. And then we could do even more. We could run this circuit on a cloud simulator from IBM. Let's try to run it and see. So here we got the output of the circuit, and then we could have the circuit drawing. Here you can see it. Then we can try other simulators. There are a bunch of other cloud simulators, and we can even run the circuit on real quantum hardware. It would take some time, so to get the response. So the purpose of this demo, we will not do this, but I encourage you to click and try to run this on the real quantum computer when you sign up for this platform. Instead, we would try to use transpiler. So let's try to convert this code to Qiskit. So now we can see this. We have the same code, but rewritten on Qiskit. We can choose from many other languages. Let's try Cirq. So we have code with Cirq, or we could try Q#, or actually we could try any language that is in the list. We can even generate the quantum algorithm code on the JavaScript. Let's stick with the Qiskit for now, and first we can draw a diagram of this circuit, and the second we could actually generate the Jupyter notebook from the code that we have here, and then we can download the Jupyter notebook. Let's download it here. And after we downloaded the Python notebook with our code, let's try to get that code here. So let's see what we get. We have some kernels installed, and now we have our code in the Jupyter notebook in our platform. So here is a Quantum Copilot. So I encourage you to go to the platform, sign up, and just try the platform, and then we are curious to learn what would be your experience, and maybe like if you kind of need some additional features, or maybe you would like us to develop something, fix something, improve your experience in any way, just feel free to reach out.